Also out in front are wind turbine samples. So these are old test articles actually that were sent here, and this is a cross-section of an old airfoil. So when NREL works with industrial partners in the wind industry, the goal is to work with small, intermediate, and large utility class wind turbines. And NREL has blade test facilities in our industrial user facility, and so whole blades can be put on a foot stand that can take several million inch-pounds of torque. And eventually they move the blade up and down and side to side, and they can crack the blade and test its, its physical structure. So this is a cross-section of a utility class wind blade, and a lot of the wind blades these days have balsa wood interiors and use hand-laid fiberglass and even some carbon fibering. But a sample like this is procured through NREL's wind test facility. It's a blade test area. And so after the test is all done, the blades are usually sawed up, and this one was brought here for educational purposes. If you come over on this side, NREL has a large dynamometer that can move up and down with the angle of a wind turbine. And so this sort of simulates the wind. And they test all the components associated with, utility class wind turbines. Both, generators and gearboxes and even permanent magnet drive generators. And so this is where the electricity would be generated in the wind turbine. The rotor rotates and extracts the kinetic energy of the wind and converts it to mechanical energy, and then ultimately to electrical energy. And that can power thousands of homes per wind turbine. And so NREL has these large wind turbines on their campus, but also more frequently we'll see new innovations, new designs coming in from industry. And NREL works on developing the testing protocols for all these pieces of equipment. Same thing for blades. Here's an example of how an older blade was tested using a hydraulic simulator. So one would actually push the blade up and down, and the other would move the blade side to side. So when they move up and down, this is called a flap motion, and this is called an edge motion. And that's the two structural loads that blades will see in nature. Ultimately, they'll usually crack the blade at some point, and if the physical testing doesn't do it, the fatigue testing, they can do a static bending test on the blade. They'll use a 53-ton crane to basically snap a blade. Here's an example of an outdoor blade test. And again, this is an older photo, but it shows how weights were added to force the blade up and down. And sometimes they'll actually use a large crane to move the blades up and down and test them. So NREL does a lot of that, but also works with industry in this area to improve, codes and standards associated with the development of wind turbines. So these are made to last, for years and years in the field. And out of all the components for blade, for a wind turbine, blades are usually the more cost-effective components. It's, the interior components that will be more expensive, but even with that said, the payback for utility class wind is very good. You can pay back in months in some cases.
Does NREL work with international manufacturers as well as domestic manufacturers?
Multinational companies do work with the laboratory. However, there should be an American intermediary. Either they should be manufacturing here in the States, or somewhere an American business that is affiliated with that research relationship benefits. That way the taxpayer investment coming into the laboratory is used properly. And NREL has a very good track record with working with various companies, keeping information proprietary, and helping to advance the industry. We don't do classified research here, but we do proprietary research. We do a lot of university work too. We work with universities. They do they do work that it's pretty standard routine, and then NREL works on the more long-term science and engineering.